Good day, everyone. My topic is all about conic sections, the hyperbola. Review. Hyperbola, the geometric definition relies on a cone and a plane intersecting it. But in algebraic definition, a set of points in the plane such as the difference of the distance from two fixed points called foci remains constant. From each point in the plane, the difference of the distances to the foci is a constant example. Look at this graph. Items reference in the graph of hyperbola, the center is green, then the yellow was transverse axis, then the conjugate axis it's yellow also, then the foci is red, then the vertices is blue. Algebraic definition of a hyperbola, a set of points in the plane such as the difference in the distance of the foci remains constant. How is the definition similar to that on an ellipse? How is it different? Fact about hyperbola equation. Equation x minus h squared over a squared minus y minus k squared over b squared is equal 1, or y minus k squared over a squared minus x minus h squared over b squared. What makes the hyperbola different from a circle? Both variables are squared. Then compare the equation of ellipse and hyperbolas. What makes the hyperbola different from the parabola? Where the center is at h key and 2a is the length of the horizontal axis and 2b is the length of the vertical axis. Procedure graph. Put in a standard form above x squared term by squared term 1. Then 2, determine if the hyperbola is opening vertically or horizontally. If x is first, it's horizontal. If y is first, it's vertical. 3, plot the center h and k. Then 4, plot the endpoints of the horizontal axis by moving a units left and right from the center to graph. 5, the endpoints of the vertical axis by moving b units up and down from the center. This is the step. How to get it? Note, the line segment that contains the vertices of the hyperbola is known as the transverse axis. The other axis is the conjugate axis. 6, draw a rectangle such that each of the axis endpoints is the midpoint of the side. 7, sketch the diagonals of the rectangle and extend them outside of the rectangle. These are the asymptotes of the parabola. 8, draw each branch of the hyperbola. Be sure to go through the vertex of each, the endpoint of the transverse axis, and approach the asymptotes. Then 9, use the following formula to help locate the foci. The formula: c squared equal a squared plus b squared. Move c units left and right from the center if the transverse axis is horizontal, or move c units up and down from the center if the transverse axis is vertical. Level the point F1 and F2 for the two foci. It is not necessary to plot the foci to graph the hyperbola, but it is common practice to locate them. Okay, 1. Ato ang i-graph, example 1 is y squared over 64 minus is x squared over 36 equal 1. 1, plot in standard form. Then, i-plot na to. Then, determine if the hyperbola is opening vertically and horizontally. Vertically because y is first. Mao na siya ang opening nato. Then identify the center. Ang center nato is 0. Then 4, identify the endpoints of the horizontal axis, 6 and 0 and negative 6, 0. 5, identify the endpoints of the vertical axis, 0 and 8 and 0, negative 8. Draw a rectangle such that each of the axis endpoints of the midpoint of the side. Sketch the asymptote of the hyperbola. Draw each branch of the hyperbola. Be sure to go through the vertex of each the endpoint of the transfer axis and approach the asymptotes. Then 10 is find the equation of the asymptotes. Y equal 4 over 3x and y equal negative 4 over 3x. Mao ni ang graph. Ang transverse axis nato is mao ni siya. Kini. Then ang conjugate axis mao ni siya. Then the center mao ni ang 0. Then ang asymptotes nato mao ni siya ang green. Okay. Kung gusto mo mag-answer, na ang example number 2 nga graph. And thank you for watching. Mao ra to.